Hey, I'm Pascal from Orangepixel, and this is the second part in a new Techtalk Tuesday series. I started last week. This is a series that we dive into the source code that created my games. These games have been released on a lot of different platforms. Last week we covered Gunslugs. This week I want to cover Heroes of Loot. And I read the messages and the comments, and I know shaky camera is off this time. And it won't be as long as last week's video. Last week I went over all the standard stuff, the globals, the generic code, and pretty much everything that's in all my games, so I don't have to cover all those bases. Make sure to check that video because it explains a bunch of things. So now I can actually dive into new games and just dive into the more interesting little things, because with every game there's some stuff I try for the first time, or I create for the first time, or I improve from the last time. So there's always some interesting stuff to talk about, and today's video we're going to talk about Heroes of Loot. Pretty much originally written for just mobile, but it has been released since on PC. It has been released on PS Vita. I think it's now on Switch. It has been released on a lot of different platforms, but originally this started out as a little mobile game written in my own code, and I then ported it in 2015 over to libgdx, started using OpenGL. So it has seen some changes in the last decade or so, but it's still actively maintained on all platforms, which is pretty cool. And there's some fun things in this top-down dungeon crawler. So after the intro, we'll dive into the source code. Alright, so I'm still changing the format of this video series. I'm just trying to find a way that it's both interesting to watch for you guys, but also easy for me to edit, so that I can actually make these extra videos on my channel, because I still have to work on games in most of my days and most of my time. These video series are also a little bit more technical than the videos I do on Thursday. Thursday is for like gamers and everybody that just wants to know how our game's made in a non-technical way, or not too technical. These videos just dive into source code, which can be boring if you're not a game developer or have no interest in code at all. So make sure if you're watching this video that you actually want to see how code works, and if you just want some more game design and non-technical versions, then check Thursday's videos. Those are much easier to get into. So let's just dive into source code. First thing you'll see here is again, and please check last week's video, these are the classes that make up the game. All these other classes are pretty much my framework. They handle a bunch of stuff and they're pretty much the same across all my games. They don't change a lot. Every now and then I improve a little bit on them, but most of these are exactly the same for all the games. Starting with just an avatar class here. This is just a little tiny class I created for the little animations that this game has. I didn't want to add all these things in the monster or entity class, so just a very simple avatar class, and they don't really do a lot in these animations. They might move from left to right or jump up and down a little bit, but that's pretty much all they do. So it's a very simple class that is only used in animations. And my bullet class is pretty much the same as in Gunslugs. Not a lot is happening here. Let me see. No, not a lot is happening here. It's simple collision checks, and I had people question or ask about collisions, and I do very simple AABB collision checking, which means you're just checking if they are overlapping in a square, and if they are, then it's a hit. If they aren't, it's not a hit. For most games and most moments in a game, this pretty much works. So you can do a lot of extra code here and checks and make sure it's pixel perfect, but most of my games, the collision detection is just this one line. And then of course we have the monster class, which is pretty much monsters, but also pick up items and everything in between, and just all the entities that do interact and move around, and not a lot in this game happening. I will accept probably a very interesting thing is go to the update version, update code. Well, pickups don't do interesting, they just stand there and wait. The altar doesn't do much, but there should be, right, the skull. Alright, so in Heroes of Loot we have a dungeon, and we have like tens or maybe hundreds of creatures running around, roaming around, and they all try to attack the player. Now, I had no idea how to actually solve this problem with so much artificial intelligence going on. So eventually I ended up with probably the easiest artificial intelligence you can create for a game. And for that I looked at Pac-Man, and Pac-Man does something pretty simple and actually fantastic because it works very well for its ghosts. It detects where the player is, the direction the player is moving towards, and then based on which type of ghost it is, it will pick a square where the player is either moving to, or if the player is moving right, the ghost might decide to always move left, and vice versa. So it's very simple logic, but it works, and it also works in Heroes of Loot. All these creatures pretty much act like the various ghosts in Pac-Man. They look at where the player is and where the player is most likely going to be moving towards, and then based on that and the type they are either moving towards that spot or moving the spot just in front of the player, or maybe just the spot behind the player. It's all very simple if statements, and that makes these creatures attack the player. So for example, here we have ghosts. They fly into the player, so their target location is going to be exactly where the player is. And a bat does look at where the player is. If he's on the right side of us and our speed isn't that at our max, then we can just increase and fly towards it. And that's how every creature pretty much tries to attack the player in a different way, and that adds a lot of variation. Of course, this could have been done a lot better. There's just this subtype is 2, subtype is 7. These numbers should have probably been names like this is the ghost, and there are probably 2 types of ghosts or 2 creatures that do the same thing, but I have no idea which one is which based on this code, so I have to actually search for it. Let's see, what is this? Skull. So apparently the skull logic does handle different stuff. Right, here we see the subtypes, and these should have all been names. So default number is skull. Then we have a ghost, we have bats, we have imps, we have phantoms, we have orange imps, we have meat spawning creatures. They spawn little extra creature thingies. We have spawned skulls. These are mini skulls coming out from one of the bosses. And that's pretty much all using the same logic. So there's very little code involved to have all these creatures attack the player, but it's I was actually very amazed when I just had it up and running for the first time, noticing that all these creatures in the whole maze were just, it looked like they know what they were doing and looked like they knew how to navigate the maze, but all they do is look at where the player is and then just try to handle those steps to get closer to it. So Pac-Man game logic, Google for it. It's very interesting, and it can be useful in a lot of top-down type games. I actually used this same logic while in the sequel Heroes of Loot 2, but also in Space Grunts, a turn-based game. It pretty much does the same thing. So most of this game actually happens in the My Canvas, which is the main class that starts the game. And I had some questions last week on where do I load all my resources and assets. So I didn't cover it in last week's video because it was already very lengthy. Let's do it in this one. Engine init, first thing we load is our splash screen, which is a little animation of the Orangepixel logo. Then we load in the player profile, which pretty much are the settings. Is the player using music? Is he using sound effects? Things like that. The first thing you want to load is that, because we also needed to set the window size on PC. Is it full screen? Is it windowed? If so, which window? What's the dimension of the windows? Then we initialize all the sound effects, and this is pretty much loading in all the sound effects needed. This is an old class. I'm using a much better, and well, actually this is in My Canvas. These days I'm using a full class for the audio, and it's much more streamlined and better. But again, this works, and it boils down to the same thing: loading sound effects. And so that we can play them later on, and loading the music. And I noticed that we are actually loading these things directly and not through a little management, which I do now, because it might take a few seconds to load all these sound effects, and you like to have a progress bar there. So again, one of those things that I improved over time with new games. But in this one I had still the old version. When this main engine initialization is done, we actually end up in our init class, and this is where we initialize our special effects lists, our bullets, our monster entities, our rooms, which are the rooms used in the dungeon creation, a sprite list because we have to sort the sprites in this case, and then we create a few other lists, and here we load in all our assets and resources. We have a bunch of files making up the graphics, and these days I all put it in one big file if possible, but like I said, this game was made before I used OpenGL, so I wasn't using textures, and if you put all of this stuff in a single texture when using OpenGL, it will save you a lot of render calls. So for this game I just had a bunch of files and creating different monsters in one series, creating all the items right here. These are all very tiny files. I mean, this is 256 by 64 pixels and it contains all the items and loot that the player can collect. And we have of course our player characters. This is the little elf. Very simple shapes and forms. I think this is just 12 by 12 pixels for the main characters. It's very tiny, but I think in Ashworld I actually used 10 by 10, so it can still be smaller. For Heroes of Loot 2 I think we used 16 by 16, but these characters had some charm to it because they're very simple, very easy, and it worked in the game. And then over here, well, this is the splash, this is the Orangepixel splash, and this is pretty much in all my games exactly the same. This logo is a little animation frame making it turn around. And then we have a tile set for a certain look of the dungeon. And this is all 16 by 16, making up all the walls that are possible, and then the game code will do a lot of checks to see which tile has to be used on which corner, so that all looks nice. And so this is where all these graphics are loaded and then used later on. So after loading all that, we initialize the controllers, and then we should be off and start showing the splash screen, which is this little animation going through the splash animation frames, and when it's done it starts the menu. And in some cases it will start the animation first, because there's an animation when you start the game for the first time, so it will pop up that animation. Now let's see if I can find something extra interesting, because I think the level generator also works from here, right? Let me see. Generate cave I think is... Alright, this is I think the entry point for the level generator, and it's not a good level generator, but at that time I couldn't do much better and it actually worked. So the problem with this level generator is that it started creating rooms randomly, random sizes, random positions, and then it would create a corridor from room 1 to room 2 and from room 2 to room 3, which is all fine, but at some point it would also overlap. So let's say we had room 6 making a corridor to room 7. That corridor could actually move straight through room 3 or 4, and at that point room 4 would suddenly have 4 doors instead of 2 doors, so you could enter and exit the room in many ways, and that made it very hard for me to actually create doors or have some flow to the game. You can pretty much move anywhere in the dungeon and end up at different rooms from different angles. Again, I designed the game around that. It was a limitation in my level generator, but I just went with it. I figured it couldn't hurt and it wouldn't harm much. It just made it impossible for me to actually add doors and stuff like that, because there was a very big chance you could ignore the door and just move through another corridor into that room without using a door. So it limited some of the design, but it also just shaped the design. So it's a good thing and a bad thing. So besides creating these mazes, we also had special rooms. Every 5th level I think creates an arena room, which is just one big room and it throws a couple of bigger creatures against you. You have to kill them and then you'll be able to exit the room and move on to the next level. And let me see if there are any other specific things I started doing in this game. Well, I think, yeah, we did add quests and things like that, but it was very simple. It just counts the amount of items you have in a game and then makes that a quest. So collect this amount of ghosts, or kill this amount of ghosts, or collect this amount of gems, and very simple quests. I did it a lot better in Heroes of Loot 2, and I might get to that in this series. Alright, so we also have animations in this game, and this was done pretty simple, and I came up with the idea to do an intro animation, and then later I decided I could do a couple of more of these little animations because they are fun to create. So again, this code started very clean, but then we ended up with different types of animations. So a bunch of switch statements, and what if, which animation are we? If we are in this one, then we should this, and every animation had different scenes. So lots of ifs and switches, but it does work. And all these animations, I've been doing animation in different games and multiple games, and usually I use all the code and stuff that's in the game already. So that allows me to quickly throw up special effects, creatures, monsters, entities. It's all in the game, but without the game code moving it. In this case, the animation code just dictates or tells these creatures or entities, go over there, move 64 pixels to the left, then jump 2 times, move 64 pixels to the right. It's pretty much a bunch of those type of if statements and code handling. Throw up some animations, throw up some special effects, some sound effects, and that's it. It's very simple animations, but it had a lot of positive feedback from players because they really enjoy these little animations, and they're very simple to create. It's just that the code is somewhat messy. Now, I have tried doing it a lot better than this game, and I made specific classes to do animation stuff, and in the end that also turns out very messy. So I don't bother with those type of things anymore. I just hack it together, and it usually works because it's very simple and not a lot of interaction with the player. So it's pretty much very easy to control on what's happening and where bugs are. So those are the animation classes, and I think that's pretty much the main stuff I've been doing in Heroes of Loot. It's the level generator, which was pretty crappy, if I may say so myself, and I think I can. I've done a much better job since, but it was my first attempt at creating procedural generated mazes. So good attempt, and it started me on the path to create much better versions. We also did the artificial intelligence, figuring out how to have all these creatures quickly decide on where to move and how to attack the player. Pac-Man logic, and seriously Google for it because it might actually help you if you're ever doing a top-down game. And I think those are the most interesting things for Heroes of Loot code. Alright, so moving forward with this series, I'm pretty much gonna tackle the important and interesting things that I've been doing for each game. So in this case, I can go over the player entity, but it's pretty much the same as the one in Gunslugs, except it's top down, but you're handling input from the player, you're positioning him, and you have an init and you have an update. It's all the same in all my games, but certain specific pieces of code is that's where the interesting stuff happens, I think. So we still have a bunch of interesting games to talk about. Ashworld is one interesting one where I did driving cars, and I've never done a racing game, but in this game I wanted cars driving through the desert and slipping and skidding, and I had no idea how to do stuff like that. So that's one interesting thing I want to talk about in a future episode. Bunch of interesting code here and there to come. Let me know if you still like these videos, and if this was a lot better for you compared to last week's video. Thumbs up, like, subscribe, comment below, share the video with your other game developer friends, and I'll see you on Thursday with another interesting residual devlog. Less technical, but probably more entertaining, because source code can be boring. I know, I'm trying to keep this as simple as possible, but Thursday, more entertaining video. See ya.